Reflection is the process by which light or sound waves bounce off a surface and return to the same medium. This phenomenon has several properties that are worth understanding. Here are some of the most important ones. Angle of incidence equals angle of reflection. The angle at which an incoming wave hits a surface is called the angle of incidence. The angle at which the reflected wave bounces off the surface is called the angle of reflection. The key property of reflection is that the angle of incidence and the angle of reflection are equal. This is known as the law of reflection. Specular versus diffuse reflection. Reflection can be categorized into two types: specular reflection and diffuse reflection. Specular reflection occurs when a wave reflects off a smooth surface such as a mirror. In this case, the reflected wave has a well-defined angle of reflection. Diffuse reflection occurs when a wave reflects off a rough surface such as a piece of paper. In this case, the reflected wave scatters in many directions, resulting in a blurry image. Reflection and image formation. Reflection plays a crucial role in image formation. When light waves reflect off an object and enter our eyes, we see an image of the object. The quality of the image depends on the surface properties of the object, the distance between the object and the reflecting surface, and the distance between the reflecting surface and the observer. Multiple reflections. In some situations, a wave can reflect off multiple surfaces before returning to the medium. This can lead to complex interference patterns and may affect the quality of the image. Polarization. Reflection can also affect the polarization of a wave. When a wave reflects off a non-metallic surface, it undergoes a change in polarization. This can be exploited in applications such as polarized sunglasses, where the polarization of reflected light is reduced to reduce glare. Law of reflection applies to all types of waves. The law of reflection applies not only to light waves but also to other types of waves, such as sound waves. When a sound wave reflects off a surface, it follows the same law of reflection as light waves. Reflection coefficient. The reflection coefficient is a measure of how much of an incident wave is reflected by a surface. It is defined as the ratio of the amplitude of the reflected wave to the amplitude of the incident wave. The reflection coefficient depends on the angle of incidence, the nature of the surface, and the properties of the medium. Total internal reflection. Total internal reflection occurs when a wave is incident on a boundary between two media and the angle of incidence is greater than a certain critical angle. In this case, the wave is reflected back into the first medium instead of being transmitted into the second medium. Total internal reflection is used in applications such as fiber optics, where light is transmitted through a fiber by undergoing total internal reflection. Reflection and energy conservation. The law of reflection is consistent with the principle of energy conservation. When a wave reflects off a surface, the total energy of the wave remains constant. Some of the energy is reflected back into the medium, while the rest is transmitted or absorbed by the medium. Reflection and color. Reflection can also affect the color of an object. When light waves reflect off an object, some wavelengths are absorbed by the object, while others are reflected. The color that we perceive is the combination of the wavelengths that are reflected. For example, a red object appears red because it reflects red light and absorbs other colors. Reflection and sound. Reflection is also important in acoustics. When sound waves reflect off surfaces, they can interfere constructively or destructively, resulting in echoes, reverberation, and other acoustic effects. Understanding the properties of reflection is therefore important in designing buildings, concert halls, and other spaces where acoustics are important. Reflection and surface quality. The properties of reflection also depend on the surface quality of the reflecting surface. A smooth, polished surface reflects light in a more specular manner than a rough, textured surface, which scatters light in a more diffuse manner. The surface quality of a reflecting surface can therefore affect the quality of images formed by reflection. In summary, reflection is a fundamental phenomenon that is important in many areas of science and technology. Understanding the properties of reflection, such as the law of reflection, specular versus diffuse reflection, and total internal reflection, is essential in understanding how waves interact with surfaces and how images are formed. These properties have important applications in fields such as optics, acoustics, and image processing.